Good evening, children. Yeah, so today we are starting this chapter, data handling. Yeah, let's try to answer, let's try to complete these statements. Okay. Average is a number that represents or shows the dash of a group of observations or data. Average is a number that represents or shows the think. The word might be new to you, but you might have heard it at least once somewhere. Central tendency. Central tendency. Average. See, we have three averages: mean, median, and mode. Mean is a measure of average of the data. Median is also a measure of average of the data. Mode also is a measure of average of the data. So mean, median, and mode, all these three are called averages. Okay, so given a data, if they ask you to find the average of the data, we normally use, if nothing is specified, we find mean. We have to find median and mode only if it is mentioned. Find median. Median is also an average. Mode is an average. Mean is an average. If the question is, they give you a set of numbers and they ask you to find the average value of the data. So you're like, average value, should I find mean, median, or mode? So if nothing is mentioned, you have to find mean. If you have to find median and mode, it will be mentioned. Find median, find mode. All right. Okay. So now what is this average? It's like, you have the school captain or the class monitor, that one person who represents the school or represents the class. Your class monitor represents the class. Okay, so like your school monitor represents school captain, vice captain, they represent the school, right? In the same way, when you have a set of numbers, there is one number that's like the leader of all the other numbers. That number represents all the other numbers, and that number is called, that number which represents all the numbers in the data is called the average of the data, which can be mean, median, or that one number which represents all the other numbers in the data is called the average of the data. So average is like, as I just mentioned, the class monitor or the school captain, okay, or the principal of a school who represents all the teachers, right? So you can take so many examples, the prime minister of our country, president. So that one person who represents the nation, president or prime minister, right? In the same way, average is that number that represents the entire data. So is the number that represents or shows the central tendency. Central tendency means all the other numbers tend to all see like that number which is called the average has kind of all the qualities of the remaining numbers in the data. With that one number, you can make out the nature or the qualities of the other numbers in the data. Representative, basically representative. Okay, so this term is new to you. Average is a number that shows, that represents or shows the central tendency. Central meaning middle tendency. The remaining numbers tend to, fall around that number. So this term is new to you. Remember, central tendency. Okay, of a group of observations or data. Mean lies between the dash and the dash observations. Mean lies between the smallest and the largest observations. Okay, mean lies between the smallest and the largest observations. Mean of a data, it always lies between the smallest value and the largest value. See, Okay, so let me make that more clear. Now, supposing you have what's the mode of this data? What's the mode of this data? 1. Mode is that value. No. Which has the highest frequency. That number, that value in the data, which happens most number of times. That value of the data, which happens most number of times. So how many times? What is the frequency of 4? 2 times. So 2. What's the frequency of 3? 1. What's the frequency of 1? 3. The frequency of 1 is 3. And what's the frequency of 5? 1. So which is that value which has the highest frequency? 1. 1 has the highest frequency. The frequency of this value 1 is 3. It comes 3 times. So that value which has the highest frequency, okay, is called the mode of the data. So mode can be this, and here what is 1? It's the smallest value, right? Among these numbers, 1 is the smallest value. So see, the mode can be the smallest value also, but mean cannot be the smallest value or the largest value. It will be between. It'll be between. It's a value that lies between the smallest and the largest value. See, you can see that mode is the smallest value itself in this example. What is mode? It's 1, and that's the smallest value of the data. All right, so mode can be the smallest value of the data. It can be the largest value also. Supposing there is 7 happening, 4 times. Then 7 is the mode. Because what's the frequency of 7? 4. 7 happens 4 times. 1 happens only 3 times. Suppose I include these numbers in the same data. Now 1 happens 3 times, but 7 happens 4 times. So which is that value which has the highest frequency? 7. So what's the mode? 7. So in this example, the highest value of the data is the mode. So mode can be the smallest value of the data. It can be the highest value of the data, or it can be any value in the data. Okay. That value or that number which repeats most number of times is the mode. And it can be the smallest value or the largest value or any other value of the data, right? But mean cannot be the smallest value or the largest value. Mean, it cannot be the smallest or the largest value. It will be a value between the smallest and the largest observations. Got that clear? Median is the middlemost value. That also, it doesn't lie between the smallest. Median is the middlemost value. But here they're asking for mean. Mean lies between. You'll have to complete this for mean. You have to complete this statement for mean. Mean lies between the dash and the dash observations. Mean lies between the smallest and the largest observations. I just gave you the example of mode, where mode can be the smallest value or the largest value. The most common representative value of a group of data is the dash. The most common means what? The one which repeats itself most number of times. The most common. Yeah, the most common meaning representative value of a group of data is mode. See that most common, which will be the most common? See here, most common representative value. That means they're asking you if it is mean, median, or mode. Who represents the data? Mean, median, or mode? One of these three represent the data, right? Representative. So we have three. We can find 3 representatives for the data. We can find mean, median, or mode. So representative value meaning you'll have to answer if it is mean, median, or mode. So the most common representative value. Most common means mode. What happens many times, right? That number which happens most number of times in the data, correct? Are you able to relate mode with these terms? Representative value means you'll have to say if it is mean, median, or mode. And it is mode because most common. Most common means that value that happens most number of times in the data, correct? Okay. A number between 1 by 12 and 1 by 3 is a number between 1 by 12 and 1 by 3 is. So I'll answer the fourth one here. Okay, so it will be 1 by 12 plus 1 by 3 divided by 2. A number between 1 by 12 and 1 by 3 is, what you have to do is add the two numbers and divide them by 2. Supposing the numbers were 6 and 4, add 6 and 4 and divide by 2. So what is 6? Supposing the two given numbers were 6 and 4, what is 6 plus 4? 10. 10 by 2, 5. So a number between 6 and 4 is 5. Supposing you were given the numbers 3 and 11. Okay, so a number, there are many numbers. A number, there are infinitely many numbers. They just want you to find one number, a number between this and this. I'm not trying to say there is only one number. There are infinitely many numbers between the given two numbers. Find one number. A number between 1 by 12 and 1 by 3 is. Okay, so again here we have more than one method. You can just use this method. So I was telling you, if the numbers are 3 and 11, a number between 3 and 11. How do you find that? Find the sum of the two numbers and divide by 2. So 14 by 2, 7. A number between 3 and 11 is 7. But you know, there are so many numbers. No, you can write 4, 5, 6, 7, 8, 9, 10, 10.5, 9.5, 9.1, 5.5. So many numbers you can write. Between 3 and 11, so many numbers you can write. 3.1, 3.33, 3.75. So many numbers you can write. So a number, you can actually see, if you have to write a number between 3 and 11, you need not use this method. You can just write a number. 10 is a number between 3 and 11. It's finished. So in this case, you have to work, right? 1 by 12 and 1 by 3. So what do you do? Add the two numbers and divide by 2. Understand the procedure? Add the two given numbers and divide by 2. Show some expression, children. Okay, yeah. So how do we add? You have to take the LCM, right? LCM. However you do it, So LCM is 12. LCM is 12. So it is 1 by 12 plus 1 by 3 into 4 into 4, right? Here it is into 1. You all know how to take the LCM divided by 2, correct? Or how do you work? Oh, I cleared everything. 1 by 12 plus 1 by 3 divided by 2. So I do it like this. So 12 is a common denominator. 1 plus, there will be into 4 into 4. Into 1 into 1. So 1 plus 4. And what happens to division? Division becomes multiplication, and take the reciprocal of 2, 1 by 2. So 1 plus 4 is 5, 5 by 12 into 1 by 2, which is 5 into 5, 5 into 1, 5, 12 to the 24. So a number, therefore, a number between 1 by 12 and 1 by 3 is 5 by 24. Understand that? Yes, I'll do it in another way, and then you can ask me a question. This is one of the ways of doing it. Okay, another way can be, okay, so what's the LCM of, 3 and 12, okay? 12, right? So 1 by 3 into 4 into 4. So it is 4 by 12. So 1 by 12 is 1 by 12. So 1 by 3 is 4 by 12. So now tell me a number between 1 by 12 and 4 by 12, 2 by 12, 3 by 12, right? So a number between 1 by 12 and what is 1 by 3? What's the equivalent of 1 by 3? 4 by 12. Okay, so you have to find a number between 1 by 12 and 1 by 3. But what is 1 by 3 also equal to? 4 by 12. So a number between 1 by 12 and 4 by 12 is, you can write 2 by 12 or 3 by 12, correct? 2 by 12. So that simplifies to 1 by 6. You can do it like this also. You can bring both the fractions to the same denominator. You can bring both the fractions to the same denominator. So 1 by 12, the LCM of 3 and 12 is 12. So let 1 by 12 remain 1 by 12. 1 by 3, the equivalent of 1 by 3 is 4 by 12. 4 by 12. Now both the fractions have the same denominator. 1 by 12, 4 by 12. Now look at the numerator. Between 1 and 4, you have 2 and 3, right? So 2 by 12, 3 by 12. Okay, you can write any one of the two numbers, and wherever you can simplify, you should simplify. Meaning when you can reduce like this, you should reduce. All right? Is it understood? You can write any answer. See, we have understood that there are infinitely many numbers between two given numbers. So there's no one answer here. You can write many. In this blank, you can fill 5 by 24 or 1 by 6, whatever. Okay. Yeah. Next one. The mean of x plus 3, x plus 6, x plus 9, and x plus 12 is. So how do you find mean? Mean is equal to sum of all observations. Sum of all observations divided by number of observations. Number of observations. Correct? That is equal to x plus 3 plus x plus 6 plus x plus 9 plus x plus 12 divided by how many observations? How many observations? 1, 2, 3, 4, 5. Divided by 5 observations. So divided by 5. Correct? So that's equal to, what is x? What is x plus x? 2x. 2x plus x, 3x. 3x plus x, 4x. 4x plus x, 5x. So 5x. Now what is 3 plus 6? 9. 9 plus 9, 18. 18 plus 12, 30. Plus 30 by 5. Add the numbers, add all the x's, and add all the numbers. Now, is 5 common in the numerator? In the numerator, in the numerator, we have an expression. How many terms are there in that expression? 2 terms. What's common between 5? What is common between the 2 terms, 5x and 30? Is 5 common? Okay, so take out that common factor 5. Okay, take out the common factor 5. Now in the bracket, you have to write, see, there are 2 terms in the numerator. So you must write 2 terms here. Now, what's the connecting sign? Plus. Okay. Now, 5 into what? 5 into what will give you the first term 5x? 5 into what will give you the first term 5x? 5 into x, right? Put that here. X plus 5 multiplied by what will give you 30? 5 into 6 is 30. So put that 6 here. Tell you again. 5 is common.
Ma'am.
Yeah, good evening.
Good evening, ma'am. Ma'am, I just now joined.
Yeah, just continue from here, Deepti. No. Yeah, you can share your messages on WhatsApp. You can follow from here.
Yes, ma'am.
Yeah. So Okay, so we have an expression in the numerator. There are two terms. The expression has two terms. What's common between the two terms? 5. Okay, so take out 5 as a common factor. Open a bracket. Now you need to write two terms inside the bracket. Because there are two terms in the numerator, you need to write two terms inside the bracket. Now, how do you write that? 5 into what will give you the first term 5x? 5 into dash is equal to 5x. 5 into x is equal to 5x. So x. Then 5 into what is 30? 5 into what is 30? 5 into 6 is 30. So 6 here. So that's how you get x plus 6 in the bracket. Okay? You don't have to put the dash and all that. Okay, plus 6 divided by 5. See here, 5 into x, 5x. 5 into 6, 30. Got it? Yeah. Divided by 5, which is already there. This divided by 5, which is already there. Now 5 and 5 gets cancelled. So the answer is x plus 6. The answer is x plus 6. So the mean of these expressions, is x plus 6. One second. Got it? Yeah, practices. Now I'll send the notes on WhatsApp. You can also carry a rough book to the class, okay? So that when you are not writing all of the class notes, so you may be just practicing. Now this one I just want you to work in the class for practice. So also carry a rough notebook. If we're not writing all the contents of the class, you can use a rough notebook to just practice. And then I'll share these images on WhatsApp. You can complete the classwork entirely. All right? Yeah, practice this one. If you don't have a rough notebook, you can just work it behind in your tuition notebook. Quickly, don't write the question, just practice the steps quickly. Yeah, over now. Yes, you want to ask something. We're simplifying further. See, now if you have a fraction like, say 15 by 25, will you leave it like this? No, right? You will simplify. You will divide the numerator and denominator by the common factor of 15 and 25. That's what we're doing here also. The numerator and denominator, they have 5 in common. So we are simplifying by taking out the common factor. This is like simplifying 15 by 25. 5 threes are 5 fives are. See, that's what we've done here also. 5 ones are 5 ones are. So when it's an expression, this is how we simplify. We take out the common factor. When it's an expression involving x, y, z, okay, so we take out the common factor like this and simplify. Done? All right? Yeah. Next one. State whether the statements given below are true or false. Average is the measure of the central tendency of a group of observations or data. True. All right, true. Average, that is mean, median, mode. It's the measure of the central tendency. All the values of the data tend to fall around a central point. All the values of the data tend to fall around a central point. That is what we call average. So average is the measure of the central tendency. Okay, I have a tendency, or I have a liking for, say, like South Indian food. I have a liking for whatever, like North Indian food or chaat, or, so like that, you have a tendency to, do something. So like that, average is the measure of the central tendency of a group of group of observations or data. Group of observations or data. All right, true. The mean of two observations always lies between them. Yes, the mean of two observations always lies between them. Because what did we understand? Mean lies between, so when you have a set of values, mean lies between the smallest observation and the largest observation. So mean always lies between the two numbers. Okay. Mean of two observations always lies between them. True. Yes, it always lies between them. In the sense, if we have two numbers, 4 and say 10, mean of these two numbers cannot be 3. Mean of these two numbers cannot be 12. Mean cannot lie outside the boundary of the two numbers. It will lie between them. Between need not always see. In the case of 4 and 10, it will be the middle value. Okay, in the case of 4 and 10, it will be the middle value. How do you find the mean of 4 and 10? 4 plus 10 by 2. So 14 by 2, which is 7. All right. Yeah, when you have more numbers, when you have more than two numbers, it can be anything. When you have more than two numbers, it depends how the numbers are, scattered. Now, for example, if you have 0, 10, and 100 as the numbers. Okay, let me make it 12. Okay. And 100. 0, 12, and 100. So what will be the mean? 0 plus 12 plus 100 divided by 0 is also a value. So there are three observations. There are three observations. 0 because it has no value. You should not disregard that as an observation. You should regard that as an observation. It is. So 0 is one observation, 12 is an observation, 10 is an observation. So totally we have three observations. So how do you find the mean? 0 plus 12 plus 100 divided by three observations. So 112. Oh, I want to make it divisible. Okay, let me make it 2, sorry. I'll just make it 2 because 102 is divisible by 3. 0, say 2 and 100. Okay. So it will be 0 plus 2 plus 100 divided by 3. So it's 102 divided by 3. So 3 3s are 9. 1 means 34. See, the mean of these three values, 0, 2, and 100 is 34. So it's not between exactly in the middle of any two things, right? That was your question, right? If it will always be the middle value, correct? Yeah, you can see here, it can be anything. See here, 0, 200, the mean is 34. Can be any value, yes. The last one. The if, sorry, one second. Yeah, if X, Y, and Z be three observations, then the mean of these observations is X into Y into Z divided by 3. True or false? False. What's the correct answer? Correct. This is false. The correct statement is okay. If X, Y, and Z be 3 observations, all that, then the mean of these observations is add the 3 values and divide by 3. Correct? This is the correct statement. X plus y plus z divided by 3. Correct? Yeah. So I think we can just leave some space for these two. See, just leave some space for now you can just come back to the first part of your book. Yeah, write the date, write the name of the chapter. Put your rough notebook aside. Yeah, write today's date, 27/20/24, in your tuition notebook. Leave a page or half a page for completing true or false these 3 statements and 5 statements of fill in the blanks. And write today's date. Name of the chapter, data handling. Data handling. Yeah, now leave sufficient space to complete the 5 statements and fill in the blanks and these 3 statements in true or false. Okay, now start working from here. Go down, go down, go down, still down. Yeah, there you can start. Take down the question. Find the mean of the first 5 even numbers. Done, children? All of you? Yeah, next one. The arithmetic mean of 5 numbers is 85. Compute their sum. Okay. So what's the formula? Sum of all observations divided by number of observations is equal to mean. Correct? Is equal to mean. I'm just writing it the other way. So sum of all observations divided by how many observations? 5 is equal to what's the mean? 85. Write the, see, there are 3 things here. Sum of all the observations, number of observations, mean. Okay, there are 3 things. Now, there are 2 values given to us in the question. What are they? The arithmetic mean of 5 numbers. So, number of observations is 5 because 5 numbers. So, number of observations is 5. The mean of 5 observations is 85. So, the mean is 85. Arithmetic mean is 85. So mean is 85. So write 85 under mean, and for number of observations, write 5. And now you'll have to find the sum of all the observations. So how do we do this? We just have to cross multiply. So sum of all the observations, sum of all observations is equal to cross multiply. 85 into 5. That is equal to 5 5 is 25, 2 carried over, 40, 42. Cross multiply. Yeah, do this. Sorry. Correct. Okay. All you can remember as a formula. Sum of all observations is equal to mean into number of observations. This is the formula. Sum of all observations is mean into number of observations. If you want to remember as a formula, sum of all observations is mean into number of observations. What is the mean? 85. What's the number of observations? 5. So 425 is the sum of all observations. Done? Okay. Next one. No, any questions here? Okay. If the mean of 26, 28, 25, X and 24 is 27. You see this? If the mean of 26 is an observation, 28 is an observation, 25 is an observation, X is an observation, 24 is another observation. So how many observations? 1, 2, 3, 4, 5. 27 is not an observation. That's the mean. Read the statement. If the mean is 27, how do you read this? See it? Don't read all this. Don't read all this. if the mean is 27. The mean is 27. If the mean of what is 27? If the mean of these 5 numbers is 27, find the value of x. So write the formula. Sum of all observations divided by number of observations is equal to mean. Whenever mean is given, you write the formula like this. When you have to find the mean, you write mean is equal to sum of all observations by number of observations. When mean is given, you write it the other way around. Sum of all observations by number of observations is equal to mean. Don't understand? Then write mean is equal to. If mean is not given, then write mean is equal to. If mean is given, write it like this. Now, how do you write the sum of all the observations? 26 plus 28 plus 25 plus x plus 24. 27 is not an observation. That's the mean. Is 27. That's the mean. Divided by how many observations? 5 is equal to 27. Is equal to 27. Now cross multiply. Okay. In the numerator, what's the sum of 26, 28, 25, and 24? 26 and how much? 103. Okay, 103. So 26 and 28 is 54, 64, 74, 79, 89, 109, 89, 99, and 403. Correct. Plus x. Correct. The sum of the 4 numbers is 103. Then that plus x divided by 5 is equal to 27. Correct. Cross multiply. 103 plus x is equal to 27 into 5. 5 7. Okay. How much? 135. Correct. Next, how do you simplify? So x is equal to 135 minus 103. Minus 103. So x is equal to 32. Yeah. So that missing observation. Okay. That is the observation which is not known, x. The value of that observation is 32. 1, 2, 3, 4. The fourth observation is 32. The fourth observation is 32. Done, children? Yeah. Find the mean of all the factors of 18. It's the fourth one. We answered 3. 1, 2, 3 we have answered. The fourth one. Find the mean of all the factors of 18. Okay. So how do we find the factors of 18? 1 into 18. In the tables of 1, 1 into 18. In the tables of 2, 2 into 9. Tables of 3, 3 into 6. 4 tables, not divisible. 5, not divisible. Then 6, 6 into 3. When it repeats like this, see 3 into 6, 6 into 3. Stop there. Stop. 3 into 6. And now you're getting 6 into 3. So stop. You don't have to go ahead. You have all the factors now here. So the factors. So the factors of 18 are, see here, 1, you can just use this U formation. See here. When I'm talking, you're supposed to listen here. This U formation like this. You see the U 1, 2, 3, 6, 9, and 18 are the factors of 18. You will get all the factors in the ascending order. You'll get all the factors. You cannot miss even one factor if you use this method. All the factors are here in the ascending order. Okay. So what did I say? Start from the tables of 1. 1 into 18 is 18. 2 into 9 is 18. 3, see, 1 tables of 1, 1 into 18. Tables of 2, 2 into 9. Tables of 3, 3 into 6. 4 tables, not divisible. 5 tables, no. 6 tables, 6 threes are 18. Stop when it happens like this. So you have 3 6 are, and now the commutative property of multiplication. 3 6 are, 6 threes are. Both are the same. So stop there. You don't have to go further. You have all the factors of 18 here. 1, 2, 3, 6, 9, 18. Write the numbers in this U formation. 1, 2, 3, 6, 9, 18. These are the factors of 18. So the factors of 18 are 1, 2, 3, 6, 9, and 18. Mean is equal to, we'll have to find mean. Mean is equal to sum of all observations divided by number of observations. 1 plus 2 plus 3 plus 6 plus 9 plus 18 divided by 6. Tell me the answer. Work and tell me. 9, 9 plus 1, 10, 15, 20, 21, 31, 39. Is the total 39? 39 by 6. How much? Okay, so that is equal to 39 by 6, right? And the tables of 3, 3, 2s are 6, 3, 13 times. So 13 by 2, which is 6.5, correct? That's what you said, right? Very good. Yeah, 6.5, correct. Got it? Yeah. Okay. The images of fill in the blanks and true or false have already been sent on WhatsApp. So go home and complete that. All right. Done, online children? Deepthi? Oh, Deepthi, I said you're not, I think you told me that you're not writing today, right? Okay, okay. I think you're just listening to the lecture. All right. All right, Deepthi. Yeah. The heights of 10 girls were measured in centimeter, and the results are as follows. Yeah. Answer these questions. Take down the question, and when you take the sub question, answer it and then take the next one. See, listen to me. Please write down the question till here. Then take the first sub question, answer it. Then write the second question, answer it, and then take the third sub question. What's the total? Danya, what's the total? No, what is the total? Numerator, total of the numbers in the numerator. 1 4, 1 4, 1, 3. Okay, let me check. What about the others? Getting the same things. Okay. 134 plus 150 plus 139, 28, 151, 132, 146, 149, 143, 149. But that's equal to 1. No. You're doing a long division, is it? You also? Ovia?
Must the answer 141.3?
Correct. 141.3. Yeah, we also said the same thing here. You don't have to divide, children. You shift the decimal point to the left by 1 decimal place. It's by 10, right? 1413 divided by 10. Whenever you're dividing by 10, 100,000, just shift the decimal point to the left. To the left. By, like by the number of decimal places equal to the number of zeros in the denominator. By the number of decimal places equal to the number of zeros in the denominator. So here the denominator has 1 0. So shift the decimal point to the left by 1 decimal place. 141.3. Yeah. What is the height of the tallest girl? 151 centimeters. So you can see that the mean is very close to the height of the tallest girl. You can see that the mean for this data, it will not always be like that. Okay, so the mean of this data, you can see is very close to the height of the tallest girl in the class or whatever. What's the height of the smallest girl? Not smallest, okay, shortest girl. What is the height of the shortest girl? How much? 128. Yeah, 128 centimeters. So the mean of this data lies or is closer to the the height of the tallest girl, right? That's just for you. See, the questions 2 and 3 are just for you to observe or compare the mean height with the height of the tallest girl and the shortest girl. That's just for you to observe. Compare the mean height with the height of the tallest girl and the height of the shortest girl. That's all. Just for that observation. try to answer this because I think data handling we also had in sixth standard, right? Yeah, so you can just try to answer. Try to answer. One second. Okay, dude, only two we have. Good. Take it down first. As you write, try to guess or recall the correct answer. Sorry, sorry. The difference between, sorry, the difference between the highest and the smallest observations in a given data. Or if it is highest, they should say lowest. 1 minute. The difference between the highest and the lowest observations in a given data is called its the difference between the highest and the lowest observations in a data is called range. Second one is range, correct. First one, data, is called data. Data. See, have you learned, you must have come across now when you study about the parts of plant, have you learned about the venation and leaves, parallel venation and reticulate venation? Yeah. So if your teacher asks you to collect data about the plants whose leaves have reticulate venation and plants whose leaves have parallel venation. So what do you mean by gather? So gather the information. So collect, that is data, right? When your teacher gives you that work, she says, get the names of the plants that have whose leaves have reticulate or parallel venation. So you collect some information, right? And that's the data. That's the data. A collection here in statistics, a collection of numbers or values gathered to give some information is called data. The difference between the highest and the lowest observations in a given data is called the range. All right. The data in tabular form is not easy to understand and interpret. Okay, so I'll tell you. Now, data is actually a set of numbers. You actually tabulate it for better understanding, analysis, and interpretation. Data, see, supposing I'm a statistician and I visit your school. Say you all go to the same school, so I visit your school. And there are about 2,000 students in your school. Okay. Now, say I come to your school with a weighing machine and with your principal's permission, every child of the school is made to stand in the weighing scale and I write down, I make a note of their weights. Make a note of their weights. So I'll have, classes like students in the age group 4 to 6, 6 to 8, 8 to 10. Get it? So I'll have some class intervals like students between the ages 4 years and 6 years. And against that, I'll be writing out the weights of the students whose age is between 4 and 6. Then I have another class interval, 6 years to 8 years, wherein I'll be recording the weights of all the students who fall in that age group. Then 8 years to 10 years. So I make every child stand on the weighing scale, and then I make a note of their weights. So what have I done actually? I've actually visited your school, and every child was made to stand on the weighing scale, and I have recorded their weights as on that day. Okay, so what the data which I've collected is called primary data because it's first-hand information. If I come to your school and get the details about the weights of the students from the records already available with your principal. Okay. So the data regarding the height and weight of the students will be available with the principal in the office. So if I just borrow that data, that is secondary data. Primary data is the data which is collected by the person who is performing, that analysis. So if I collect the data personally, then that's primary data. Now I have 2000 numbers in front of me. What will I do though? Because I have the weights of 2000 students, right? So I have like 30 kgs, 85 kgs, 50 kgs, 52.5, something. So randomly, so many numbers I have, 2000 numbers I have. Now, what can I study with these 2000 numbers? They'll only be like, I really cannot come to any conclusion with looking at the 2000 numbers, right? So what do? I need to tabulate these numbers. And how will I tabulate? So I need to tabulate, like I told you, weights of students weights of students in the age group 4 to 6 years, weights of students in the age group 6 to 8, 8 to 10, 10 to 12, 12 to 14, and 14 to 16. Only 10, up to 10th standard, from LKG to 10th standard. So I'll make these class intervals like this. Okay, so there is a procedure to tabulate the information using tally marks. Okay, using tally marks, I'll be tabulating the information. So tabulating is done to further, observe the data, analyze and interpret. So tabulation makes your work easier than having 2000 numbers in front of you and trying to understand something from 2000 numbers. When you tabulate the numbers, when you put the numbers in the form of a table, it's easier to study from the table. Okay, so the statement here is the data in tabular form is not easy to understand and interpret. No, in tabular form is easy to understand and interpret. It is easy to understand and interpret. So this is false. The data in tabular form is not easy to understand and interpret. No, data collected is just some numbers. Like in my case, 2000 numbers. I have to tabulate these numbers. I'll have to arrange the numbers in a table, in a tabular form, using 2-3 columns, wherein tally marks is the most important thing that I'll be using. So tabulating the data helps me to analyze and interpret the data better. So tabulating makes your work easy, but here it's given not easy, so it's false. The range of a data can be negative. Yeah, because if it depends on the values you have. The range is what? The highest value minus the lowest value. Highest value minus the lowest value. So can it be negative? Okay, let's take an example. Now, supposing the highest value is is say 0, and the lowest value is minus 50. What's the range? What's the range? Highest value minus the lowest value. Highest value is 0. minus the lowest value. No, you should. Yeah, now you work and tell me. You take. See, you can. You see here. I've taken 0 and a negative value. You take both the values as positive, both negative, one positive, and check and tell me. Take both the highest and the lowest values as positive numbers and see what happens. Both negative and see what happens. One positive, one negative, and see what happens. Hmm. Hmm. Sorry? Hmm. Okay, see here. Tell me your values. We'll just make a table. Highest value, lowest value. All right. Lowest value and range. Okay, so I took what first? I took the highest value, some no 0, and the lowest value is minus 50. Then what's the range? 0 minus 50. Highest value minus lowest value, which is 50. Right? Okay, now you tell me your highest value. Minus 5. Okay, then the lowest value? Minus 1, 3. 1, 3. Okay, so then what's the range? 3, 0. Okay, 3, 0. Okay. Okay. Yeah, now what's range? Highest value, minus 5, minus the lowest value. You should not write minus 30 first. Minus 5, the highest value minus 5, minus the lowest value minus 30. So it's minus 5 plus 30, which is 25. Then it's the highest value minus the lowest value. You must write the highest. See, the highest value is minus 5, the lowest value is minus 30, and you should put a minus in the middle. Highest value minus the lowest value. So you should tell me your conclusion. So it can be what? The range of a data can be negative. True or false? False. It can't be negative. The range of a data can be negative. No, it cannot be negative. Give me an example. See, take another value, say like 10 here, and lowest value minus 5. So range is highest value minus the lowest value. Minus the lowest value. So it's 10 plus 5, 15. Then the range of the data is always from the data. The range of the data is always from the data. Now you can see in this case itself, what was the highest value? 10. What was the lowest value? Minus 5. So that means the other values are between 10 and minus 5. You can just use this example. The highest value is 10. So there is no value higher than 10. The lowest value is minus 5. So there is no value lower than -5. So there's no -6, -7, -8, no. So all the values are between 10 and -5. But what is the range? 15. And what is 15? It's outside the data. 15 is outside the data. The highest value is 10. But the range is 15. When both are negative, see here, see this case where both are negative. The highest value is negative, the lowest value is also negative. What's the range? It's positive and it's 25. Where is 25 in this data? This data has only negative numbers because the highest number is -5 and the lowest, highest number, meaning the highest observation is -5 and the lowest observation is -30. So all the observations are negative. All the observations are negative, but what is the range? It's positive, it's 25. What is the statement? The range of the data is always from the data. No, 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 it need not be. Yes or no? It need not be. So the data in a tabular form is not easy to understand and interpret. False. It is easy to understand and interpret when it's in the form of a table. The range of a data can be negative. False. It cannot be negative. It's positive or it can be zero also. We'll not discuss that now, but it can be zero or positive. The range of the data is always from the data. No, it need not be from the data. It can be away from the data also. All right, write down quickly. Done. You should have made a note of this table also. If you haven't, please do it now. Just write these examples of highest values, lowest values, and range. on it. Yeah, this you can. So from this table, you can make out that the range can be 0 also. I was telling you here, no? That the range, the second statement, the range of a data can be negative. The range of data can be negative. I said false, it can be 0 or positive. The range of a data is always positive, or it can be 0. Okay, so see here, in this case, this is the data. Now, supposing in a class of 5 students, all of them have scored 8 marks, 8 out of 10. In a class of 5 students, okay, all the students have scored 8 on 10, 8 on 10, 8 marks on 10 marks. You understand that? Okay, in a class of 50 students, all the students have got 8 out of 10. So what are the values? 8, 8, 8, 8, 8, 8, 50 times. So what's the highest value? 8. What's the lowest value? 8. What's the range? 8 minus 8, 0. So it is possible to have range as 0. All the students of the class have got the same score. Same score. Then the highest score, the lowest score, both are the same. In that case, the range is 0. Okay? Yeah. So I'll just send this image. Please complete this. You just have to match the first column, the observation, the first column to the second column. First column is observation, second column range. Okay. There should be some image that's missing. Some integers are marked on a board as shown below. I've missed to put that image. So we'll take this question in the next class. Range, all this is very easy. Yeah. So, yeah. Try this question. Write down this question. So just make a note of this somewhere on top of the page. How do you find range? Range is equal to highest value or highest observation or whatever. So highest value or highest observation minus the lowest observation. Highest value minus the lowest value. Range is equal to highest value minus lowest value or highest observation minus lowest observation. So what are the different numbers you see here, children? What are the different numbers you see here? You find this number 15, then 22, 21, 20, then 18, then anything else? The different numbers here are 15, 22, 21, 20, 18. Any other number you find? Okay. So see here, this is how we tabulate the data. This is how we tabulate the data. So we say frequency table. Listen, frequency table showing the length in centimeter of 30 carats. This is the table heading, frequency table showing the length in centimeter of 30 carats. That's the heading for the table. Okay. Now the first column in the table, length in centimeter. Second column, tally marks. Third column, frequency. Okay. Now length. What are the different lengths you see here? write the values in the ascending order. 18, 20, 20, 15. 15, 18, 20, 21, 22. Yeah, now look at the board. Now 15. 15. See here, stop writing. 15. 22. 21. Yeah, tell me the next number. 20. Next number. Yes. Loud, loud. Okay. Till here, we understand? Till here? Yeah. Tell me the first number in the data. 15. The second number in the data. The third number in the data. Fourth number. Fifth number. Huh? இந்த சத்தமா சொல்லுங்க எனக்கு வந்து ஒரு நிமிஷம் இருங்க. Why you so soft? சத்தமா இந்த நம்பர்ஸ் படிங்க. 15, 22, 21, 20, 22, 15, 15, 20, 20, 15. சத்தமா சொல்லுங்க. எனக்கு காதே கேட்கல. ஃபர்ஸ்ட் டைம் சொல்லுங்க. இதான் உங்க ஹையஸ்ட் பிட்ச் தானா? ஆ. மெதுவா 20 20 அப்புறம் 21 20 இப்ப ஒரு நிமிஷம் 20 இப்ப ஆல்ரெடி we have 4 tally marks, so you should cross the 4 like this. Now this is 5, this bundle is 5. இப்ப எங்க ஸ்டாப் பண்ணோம்? 20 ல ஸ்டாப் பண்ணோம். கண்டினியூ பண்ணுங்க. 22 21 ஓகே 21 18 21 18 20 20 18 20 but 21 ல already we have 4 tally marks. Fifth one வந்து இப்படி போடணும். Now this is a bundle of 5. இத பார்த்தா 5 இது. Then 18 18 correct she's right. 18 22 20 15 21 18 20. You understood what I did? So now count the tally marks. 5 10 okay, now let's write the frequency against every length. So 15 centimeters length la evlo carats irukku? 5 carats irukku. 5 carats have length 15 centimeters. 6 carats have length 18 centimeters. Then 5 plus 3 adana kete if she's right in 5 plus 5 10 11 5 10 15 20 24 25 26 29 தான் இருக்கும். Yeah, one value is missing. Let me see if it's 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 25 26 27 28 29 30 21 so see we have to do it all over again. அதனால தான் ஃபர்ஸ்ட்ல இருந்து நம்ம எந்த வேல்யூ மிஸ் பண்ணாம நான் ஸ்லாஷ் பண்ணிடுறேன். ஒரு நிமிஷம் இருங்க. ஸோ 15 எங்க வரும்? இங்க 15. தென் 22 here 21 21 20, 20, 22, 22, 15, 15, 15, 15, 20, 20, 20, 20, 15, 20, 15, 20, 18, 20, 18, 20, 22, 21, 22, 21, 20, 21, 20, 21, 18, 21, 18, 21, 18, 20, 18, 20, 18, 21, 18, 18, 21, 18, 22, 20, 22, 20, 15, 21, 15, 21, 18, 20, 18, 20. So you can do it like this. You can just slash the numbers. இப்போ நீங்க பண்ணிட்டே இருக்கீங்க, யாரும் உங்க ஃப்ரெண்ட் உங்களை டிஸ்டர்ப் பண்ணிட்டாங்க, கூப்பிட்டு எனக்கு எரேசர் கூட அப்படின்றாங்க. ஐயோ நான் எங்க ஸ்டாப் பண்ணேனே தெரியல. இப்போ 100 நம்பர்ஸ் இருக்கு, நீங்க 40க்கு மேல வந்துட்டீங்க and your friend disturbs you. Now you cannot, like, now see, I had to do everything from the beginning. So what you can do is, every time you use the tally mark for the number, you can slash it like this using a pencil. Exam நீங்க இதான் பண்ணணும். கொஸ்டின் பேப்பர்ல ஒரு 50 நம்பர்ஸ் இருக்குன்னா நீங்க ஒரு நம்பரை யூஸ் பண்ணதை ஸ்லாஷ் பண்ணிடுங்க. ஸோ ஈவன் இஃப் யூ ஆர் டிஸ்டர்ப்ட், okay, interrupted in the middle for some reason, you don't have to come again from the beginning. You can continue because you have slashed the numbers which you've already used. You have slashed the numbers for which you've already put the tally mark, right? You can just continue. Yeah, do this. So frequency 5. What's the frequency here? Next. Loud and fast. 9. Next. இப்போ the total பண்ணுங்க. 6 plus 5, 11. 11 plus 9, 20. 20 plus 10, 30. Correct தானே? 30 numbers இருக்கு. Frequency, the total of the frequency column should be equal to the, the total number of observations here. இங்க 30 observations இருக்குன்னு கொடுத்திருக்காங்கல்ல, 30 carats. So the total of the frequency column also should be 30. What are these numbers given? They are the lengths of the carats. There are 30 carats, and the length of the 30 carats in centimeters has been given to you. And that's what we have tabulated. Now, when you tabulate, see, when you see these numbers, you cannot make any interpretation. But when you see that the same numbers are now put up in the form of a table. So see, you can read from the table so easily. 5 carats are of length 15 centimeters. 6 carats are of length 18 centimeters. 9 carats are of length 20 centimeters. 6 carats of length 21 centimeters. And 4 carats of length 22 centimeters. Okay, so most of the carats are of what length? Most carats 20. So 9 is the highest frequency, right? So most of the carats, so 9 carats are of length 20 centimeters. So like this, you can answer various questions when you represent the numbers in the form of a table. Correct? So table makes it easy to understand the data. Table or tabulating the data makes it easier to understand the data. Now, whatever question you get in your mind regarding the length of the carats, all the answers you can get from the table by just looking at the table. Right? So what is the number of carrots which have length more than 20 centimeters? How many carrots have length more than 20 centimeters? 10, correct? 10 carrots have length more than 20 centimeters. Then which length of the carrots occur maximum number of times and minimum number of times? Which length of carrots occur maximum number of times? Maximum is 9, right? 20 centimeters. And which length of carrot occurs minimum number of times? 22 centimeters. Correct? Carrots of length um, 20 centimeters occurs maximum number of times, and carrots of length 22 centimeters occurs minimum number of times. For A, the answer is 6 plus 4, 10. For B, you look very happy today. A, B answers. A, what is the number of carrots which have length more than 20 centimeters? 10 carrots have length more than 20 centimeters. Answer for A is 10 carrots have length more than 20 centimeters. Have you written as a statement? You must write. Yeah. Take down this question. Sorry. One second. 1, 4, 5, 6. Okay. Okay, we'll do one thing. We'll just answer these and I'll share the images. You can complete it later. Yeah, ages. The ages in years of 10 doctors of a hospital are as follows. So you can see there. What is the age of the oldest doctor and that of the youngest doctor? That you can answer, right? And what's the range of the ages of the doctors? How do you find the range? Highest value minus the lowest value. You can answer this. Okay, then. Again, what is the highest marks of the class? Lowest and the range. How do you find the range? Highest mark minus lowest mark. Here, see, you can write the formula specific like that also. Range is equal to highest mark minus lowest mark. Here you can write range is equal to highest age minus the lowest age. You can write a meaning formula specific like that, or you can write the general one. Range is equal to highest observation minus the lowest observation, or maximum value minus minimum value, anything. Range is equal to maximum value minus minimum value, or range is equal to maximum age minus minimum age. Here, highest mark minus lowest mark. Okay. So here also age it is. Age of the oldest family member and youngest family member, and what is the range of the ages of the members. So range is equal to maximum age minus minimum age. Right. Okay, so I'll share these questions on WhatsApp. So complete all this by the next class. All right, children. So that's it for today's session. Thank you. And Deepthi, if you're there online, that's it for today's session. You may leave the call, Deepthi. Thank you.
Yes, ma'am. Thank you.